Hi, I am Mohamed Amjad Al Awawda, KIB 190706 from Group 9. Today we are going to present a real-life example for dynamics. Pushing a heavy box that is lying on the ground can be quite difficult for even a larger muscular adult. A contact force is any force that is transmitted by a physical contact of two bodies. Contact forces include push or pulls exerted with your hand, the force of a rope pulling a body to which it is tied, and the friction force between an object and the surface upon which it rests or slides. To illustrate this, imagine pushing a box across the floor. If the magnitude of the force that you exert on the box is small, the frictional force acting in the direction opposite will keep the box from moving, and the box remains in a state of static equilibrium. If the magnitude of the force is gradually increased, the box will begin to move across the floor. Once the box begins to move, however, it requires some force to keep it moving at a constant velocity across the floor. Because the box is moving at a constant velocity, it is in dynamic equilibrium. Thus, the force of friction between the box and the floor must be equal in magnitude and opposite in direction to F. So, from that we will get the magnitude of P and the work done.
Hello, my name is Abdullah Brahim Ahmed Abu Abid. My metric number is KIB 190705. First, for this box, we're going to need to draw a free body diagram. And for the free body diagram, we're going to have the weight, which is going to be downwards. And because there is a surface underneath the box, we're going to have an upward force. We're going to call it N. And also we have the initial velocity, which equals to 0, and the velocity which equals to final velocity, which equals to 6, and also the mass of the box equals to 60 kgs, and also the coefficient of the cement, which is the underneath the box, equals to 0.8, and the distance that has been moved is 2 meters. Now we're going to need to find the acceleration of the box. To find the acceleration of the box, we're going to use this formula, and by this we can substitute the v with 6, and the initial v with the 0 and 2. We start substituting to find the final answer, which is going to be A equals to 9 meters per second squared. Now we're going to need the total of Fy, which is total of Fy equals to 0. We're going to need to use the W and the N, this because these are the forces that are on the y-axis, which equals to negative P sine of 45 degrees equals to 0. We start substituting the W, the weight of the box, with the mass, and we use 9.81 as of the gravity that's pulling it downwards. And then we found N equals to 588.6 minus P sine of 45. Now we want to find the f of x, which is the total of f of x equals to ma. We're going to substitute the f of x with the P cosine 45 plus 40 and 20, which are the forces that have been pushing the box, minus 0.8 n, which is the coefficient of the cement, which is underneath the box, equals to 60 kgs times 9. 9 as in the acceleration we just found, and 60 as in the mass. And then we start calculating and finally I found the answer equals to 747.08 n. Now we need to find the work done. To find the work done, W is going to be equals to f of cosine theta times d. The f of cosine theta, f is going to be the P we just found, so we substitute f with the P that we just found, and then the cosine, we're going to use the 45, which is the degree above, times the distance, which is the 2 meters here that we've been given. And the final answer is going to be W equals to 1056.5 J. That's all. Thank you.